When I volunteered to put together this mini Connect-a-thon, I had no idea what the background of the people were going to be, or how we could even actually expect to do any real programming when people didn't have stuff set up already. Because if you've ever really done anything with FHIR, you know you've got to not only download the language package, but then you've got to get a bunch of jar files together if you're in Java, or you pull together the environment if you're in C# on .NET. And it takes a couple of hours anyway to get configured, and it wasn't reasonable to imagine that very many people were going to be able to do that in the rest of our afternoon. So the first question that I asked when I came in here was to see sort of where we were on the spectrum of expertise with FHIR. And what I see now is that we are more in the former camp than the latter. But I did find a couple of people that I talked to who were interested in the very advanced stuff. And so I don't exactly know how to do this. But how many people speak Java here? Okay, how about C#? Pascal? I speak Pascal. I actually spoke Pascal in the 70s, though, and it's been a long time since I've written anything in Pascal, but I remember being very impressed with that language and getting it running on a Hewlett-Packard desktop computer. There's a lot of languages that you can use. Really any tool that can form an HTTP request, a GET, a PUT, a POST, a DELETE, can be used to access FHIR. If you really want to do serious stuff, you need a programming language because you're going to be chaining together multiple requests. And so what we're going to do first is do some simple stuff. And I'm going to hope that you have your laptops out and you're all ready, because here's a bunch of resources. Mainly the first one is just the FHIR reference itself. The second one is how you can download the software if you want to decide you want to actually do some programming. There's a development overview page. These are all pages that you can access from the top of the FHIR server tree itself, but I thought I'd point them out to you because they're interesting. So the developer's overview tells you how you can really, how is it that you phrase the requests, the gets, the puts, the posts, the deletes, and so forth. Let's see, what else is there? There's a list of publicly available FHIR servers. It's a rather large list, and it's growing all the time. And there's a wiki for those of you who want to get more involved in the machinations around FHIR. There's a nice cheat sheet that I recommend for everybody who wants to do queries. You can download that from that website. And I won't dwell on these because I don't really expect that anybody's furiously typing at this point. One of the things that got me into FHIR was working with the patient generator. And I don't want to give a lot of talk about the patient generator, except to say that it's been under development for the last couple of years at MiHIN, and it has been really focused on producing Category 1 clinical quality measure reports. And these Category 1 reports are all CDA, sort of XML, horrendous things that systems can actually consume better than people. And in the other room when I was gone, I was talking about how we actually just got Patient Generator to actually take the Category 1 reports that it generated for the 19 Michigan personas and actually ship those via direct to the mitigate catcher in the rye down here that we have that funnels those in through our clinical quality measurement plumbing, and the Category 1s get converted into Category 3 reports. The Category 3 reports then get displayed using Tableau, and in the other room, if you were there, you would have seen some example screenshots of how we can allow a an organization administrator, such as for a provider organization, to be able to drill down into various practices and see how those practices are doing on a number of different quality measures. And we think this is going to make the use of this information much more realistic and much more useful, especially if it comes in real time. Well, where do you get large volumes of clinical quality measures that contain protected health information for testing purposes in real time? Well, that's why we built PatientGen. And then I learned about FHIR, and what I realized was that on the left are all the internal artifacts that get generated to produce these Category 1 reports. People and providers and hospitals and practices and specialties and a lot of different coded concepts and value sets and conditions and procedures and encounters and acts and observations, and all of these things already existed because we were producing clinical quality measures. And lo and behold, when I learned and read about FHIR, they had all those things too. They were just really JSON representations of all the things that were already inside Patient Generator. So I started off working with Adam Culberson last August, and we got patients and practitioners and organizations and bundles, those aren't on the list, operational, and I produced a bunch of test data for the first patient matching connect-a-thon. And then Graham Grieve was there, and he thought what I was doing was interesting and encouraged me to continue, and so I worked over the next couple of months of fleshing out some of the other resources. And so now it generates at least 16 different resources. You do want to go to this website, and I'm going to leave it up there for a while so that if you have a laptop, you want to go there. This is MiHIN's publicly facing HAPI-FHIR server, and it is populated with a couple 100,000 observations and patients and resources from the Patient Generator has produced. It's being accessed, and you can access it from your web browser and or your programming language or CURL or any other tool that you can use to access a FHIR server. It's a very, very nice web-based interface, and I encourage you to go in, and we're going to go through a little bit of an example on how you might want to do some of that and explore some of these resources and see what they look like. I wish I actually had my laptop plugged into this so that I could do these for you. But for example, you can go to the website, and it has down the left side a number of different resources. And you can click on any of those resources. But if you click on patient, then it's going to do a query for patients, and it's going to generate a page that has some client code that you could use to actually do that very query, the get that it did. It's going to have a search button that says, do you want to search for these patients, or do you want to do some CRUD operations on them? And if you click the search button, you're going to get a list of the first 10 that it found. And you can look at those and see what the JSON representation is. You can also click in the upper left-hand corner of the website and say, I'd rather see them in XML because I really like XML. And it'll produce them in XML for you if you're a masochist. You can also do things like click on the CRUD operations tab and enter a patient identifier. Patient ID 1119 is Tricia Franklin. She's one of our personas, a young woman who's pregnant and who has a history. Not a history, it's a negative history. She has a future in this repository that includes a son and his son's wife and children. We have all the other personas in there as well. And you can, the Patient Generator adds, using FHIR extensions, the family trees of all of the parents who have children and spousal relationships that exist, so that you can actually go through and traverse the whole family tree of a given person or of a number of people. And I produced a bundle of Tricia and all of her children and their children and their children in the simulation. I put it in a bundle along with all of their medical histories, and I sent it to Graham Grieve, and he said, Jeffy, it doesn't pass the validator. So I went back and I pushed it through the validator, and now it does, and so I sent it back to him. So the ball's in his court now. But there's a growing amount of interest in getting this kind of synthetic data into FHIR servers around the world, because it's evidently relatively complete or more complete than a lot of the test data. And because it is completely synthetically generated, it has no protected health information. And I missed Mark Bronstein's discussion of what his students did because I was sequestered over next door. So I hope it was interesting. Was it? Oh, cool. Okay, so this is something that you can do. You can look at the JSON. Even if you're not a programmer, you'll find you can read it. So you can pretend you're a doctor. And you go, okay, well, I can deal with those funny little curly braces and brackets and so forth, but I can see that here's a LOINC code, and here's a diagnosis, and here's a procedure, and so I have a pretty good idea what's going on here. If you're going to be a programmer, then you're going to be worried about how do I create records, create resources on a server, how do I search for them, how do I get them, how do I update them, how do I delete them, and these are all standard operations in the RESTful dialog. FHIR supports search and history using get, and why does that say get post and delete post? I think there's a typo in my slides. I hate that when it happens. Anyway, delete most of those posts. Just take the first word out of those. I don't know why I missed that late up at night. If you're a programmer in Java and you want to get a patient resource, then you write a little program, something like the one on the top, and you build a URL, and you ship it off to the FHIR server using the get string that's down below. And what you get back is a bundle that contains the result that you asked for. And it's a small program. It's pretty easy to write. It's harder actually to get the system configured with all the jar files that you need and do that first communication, and then you go, oh, okay, this is good. I can do this. I can do more of this. Here's the code you need to find all of the encounters for a patient, for example. You're going to put together a URL which says I'm looking for a patient reference. I'm looking for I'm going to search for all the encounters for one that has a patient reference to patient 11761. And the rest of the code is just really running the test and making sure that I got back a result 200 and then parsing it into a JSON, parsing the result into a bundle and then asserting that the bundle is not null and then outputting the bundle. And you can't really see the bundle down below, but you can see it's not very hard to put together a query like this. And so you might imagine that your more clever programmers could do this fairly easily. Why did we get into using FHIR within MiHIN? Because we have some directories and we have some services, and those services are built using RESTful technology, and we didn't want to have to invent things if we could just use things. It turns out FHIR's got all kinds of resources that are useful in a health information exchange. Go figure. And so I'm the architect of the provider and consumer directories, and we have implemented on Salesforce a population of providers. That's the health provider directory, and it contains providers and their organization affiliations and their electronic delivery preferences. For example, when a transition of care message comes into the transition of care service because a hospital sends an ADT to MiHIN, and MiHIN goes into the active care relationship service. You've seen this, right? We've walked through these things, and other people have. They look up the delivery preferences in the health provider directory, and they get this information out of the HPD. The consumer directory is just starting to poke its head out the door, contains consumers implemented as patients and their affiliations and their delivery preferences. And it's a way for us to support consumer-facing applications and to give consumers a way to have visibility and have control over how their health information is exchanged. And the active care relationships that come to us from the ACRE service tie all of those together. All the resources live in the same Salesforce instance. The HPD objects are mostly public. The SCD objects are mostly private, and we use Salesforce data sharing rules to keep them separate and secure. So why am I talking about this? Well, we needed to have a RESTful API to this combined directory so that people could use, because we wanted to move from big batch CSV file inputs that people send us every month, and Amrutha over there has to load and run all these things, and it's a huge non-scalable process. We'd like to offsort that so that we get these organizations to send us transactional updates to their active care relationships. And that means they've got to tell us about organizations and providers and consumers, patients, and the affiliations between them and the electronic services and so forth. And so we needed an API with those kinds of things in it, and turns out FHIR has 80% of them. So what we decided to do was we would work within the constraints of FHIR and use FHIR wherever possible, and then extend it wherever necessary, and then work with the FHIR community itself to help close some of the gaps, because it's still, FHIRs were not really aimed at provider directory or consumer directory kinds of missions. It's aimed at representing clinical information. It's really much better at that than it is at health provider or consumer directory stuff. So we found we needed to do some, to take advantage of some of the extension mechanisms, but we could use a lot of the existing FHIR resources and FHIR APIs, and we didn't have to invent something when we had a nice definition to use. And so we basically did a profile on the FHIR definitions for example, an organization. Well, here are the standard fields in a FHIR organization from that resource, and then we found we needed a couple of extra things that we had to do as extensions. Qualifications, because the credentials, we need to store credentials. That's probably going to get added to FHIR here shortly. We needed to store taxonomy, the specialty information, in a way that wasn't being stored in FHIR in order to be able to match our IHE derived provider directory, and we needed electronic services to be defined so that we could store and manipulate these endpoints. Same thing with practitioners. Practitioners were actually a better fit. Provider directory is full of practitioners. We only needed a few things to be extended there. The reason I'm showing you this is that we're putting this API into production. It's available today on a sandbox FHIR server, a Salesforce server, and those of you in the advanced category can come to me to get the credentials you'll need to access it. I just want to go through a little bit more and talk about one of the areas that FHIR doesn't deal with as well that we needed was a rich set of memberships, relationships between organizations that are very general and allow us to talk about organizations that are part of another organization, that are members of another organization, that might be a service provider to another organization. Organizations in the medical business have a lot of affiliations, and we wanted to be able to represent those because some of them are germane to delivery of the electronic services that we do through MiHIN. And Providers also have a number of relationships that aren't easily represented using the native FHIR resources. And consumers have relationships with organizations that aren't represented using the FHIR resources. So I decided rather than adding different extensions to each of those primary resources, that I would introduce a new resource. And FHIR has a mechanism called the basic resource, which allows you to define your own new resources. And we're actually working as much as possible with the FHIR community to rationalize these and defend a little bit these extensions, but we have an immediate production need to get these available so that our consumer directory can be accessed and so that people can access our consumers' delivery preferences for things like advanced directives, personal health record systems, sharing information with different organizations, and so time's of the essence. Electronic services, also an entity that FHIR does not address. It's critical to our role as really a router. We thought people were going to log into these directories and doctors were going to be updating their information and everybody was going to be happy, and they're just not interested in that. So what we've really done is we've turned it into more of a router. We got a lot of bulk feeds that we'd like to turn into transactional feeds. We have exports of the resulting data structures that we output to the operations team on a regular basis because they don't want to be hitting the directory every time an ADT message comes in. We get 5 million of them a week. It's just to be a denial of service attack against Salesforce. But the data doesn't change all that much and we can output it on a regular basis, and so we're using this as a strategy. So this is what an electronic service looks like. It's also implemented as a FHIR basic extension. If you go to the website that I showed you, the HAPI-FHIR server, and you click on basic and you do a search, you'll see memberships, electronic services, and service descriptions. You'll also see patients. Patients had a really good mapping. We didn't have to extend patients really at all. Active care relationships. This is a critical ingredient of the association between patients and providers and practice organizations in the directory. It's critical to our routing of a number of different service message types. FHIR is, in the next release, going to introduce care teams, which are very close to active care relationships, but which aren't quite exactly right. And anyway, that's not a standard we can build on. We have DSTU too. So right now we have active care relationships, and we're working within the FHIR community to try to figure out how to use the new care team resource that they're building, because it has a lot of thought in it and it satisfies a lot of other use cases that ours don't. But it doesn't quite exactly have all the information in it that we need. So we might just choose to extend that, but once the STU comes out later this summer, we'll evaluate that and go forward. So active care relationships, another FHIR basic extension. Service descriptions, another FHIR basic extension. When you decide as an organization that you want to offer a consumer-facing application, how do you describe that to users in a way that would allow them to make an educated choice? We're implementing a service description object that captures that information in a human-readable form, a human consumable form, and allows you to search for services of a certain type and then go through the enrollment processes and enroll in that. Aaron Seib talked about the Trust Harbor as a vehicle for registering and offering these kinds of service descriptions, ways of vetting them and having organizations certify them, There's a lot of work to be done to make this be a practical thing that has wide ubiquity, but we had a requirement for the consumer directory to be able to have a kind of an app store, if you will, of applications that people could sign up for, and this is the vehicle that does that, and the server, the HAPI-FHIR server, has instances, some service descriptions as well. The HAPI-FHIR server is public. It has no authentication or authorization. You can access it. You can update information. In fact, as soon as I put new information up there, I did a run because I'd evolved the program a little bit. As soon as I did that run and pushed the new population up there, Mark Bronstein's students were already adding resources. And other people, we get people from all over the world. If you look at the EEG of the server, it's running 24/7. So people are banging on it from all over the world. And immediately new resources start popping up on there, not in large numbers, but indicating that people are not only reading, they're updating, they're creating new objects, and it's something that's very rich and very open, but for our consumer directory, we need a little bit more access control. And so for that, we're using Salesforce access controls. Salesforce has built-in data sharing rules that we can use to configure. Each user that logs in is associated with a contact in the directory, and when they log into the directory with their credentials, they get access to that contact's private information. So when Tricia Franklin logs in to the consumer directory, she can see her information, but she can't see Joan's or Jerry's or any of the other people's that are in there. And this requires a different kind of authorization flow. We use OAuth the same way that the other FHIR projects are using it. I don't know if we're using it exactly the same way because we're constrained to the Salesforce approach. Salesforce has a couple of different login flows. We have a common gateway service in MiHIN that is an agent for receiving a lot of different requests, and when it logs in, it has a well-known user account, and it has different permissions than Tricia does when she logs in because they can read everything, because they're using the routing data that we have in the directory. For individuals logging in, we're using the bearer flow, and there's a link there in the slides that I think is actually live. It talks about how to do that. I'll just show you briefly how you do that. You send, well, this is the web server access flow. This is the one that I'm prepared to support for you folks. If any of you are really interested in banging on the consumer directory / provider directory and using the resources that I've just talked about, we have a client key and a secret and a username and password and security token file that I can send you, and you'll need to ask me in an email to eastman@mihin.org, and I'll let you access that, and then you can begin to use the API, and you can hopefully tell us if we've missed something, because I'm sure we have. We've been writing a lot of unit tests for it. But the idea is that once you get an account and once you log in like that, then you can do gets and puts and posts and deletes to this directory. It has no protected health information in it. It's all patient gen data. And anything that you find that you have time to do would be appreciated by the MiHIN team. So here's some code that is what you would do to log in to get an OAuth token. I won't spend a lot of time on this because it'll be in the slides. And then here's what you do to get a patient resource. Well, it actually looks a lot like what you would do. In fact, you can use the same get that you would use to the HAPI-FHIR server. Once you've gotten that login, that access token, the only thing you do is you send your get with a different authentication strategy through HTTPS. And you'll get back the data that's in the consumer directory. And here's searching for a membership. I showed you the previous, how to do that in the HAPI-FHIR server. It's the same, the only difference is the access token has to be present. Are there questions? We have several. Adam?
So the last example, that was written in Java?
Yeah.
Okay.
All those are written in Java.
In some of those APIs, how those APIs connect to the database? Does those resources, like the attributes of those resources, have to be same on the database side also, or is this an implementation on the payer side or any company?
Well, we've implemented the FHIR APIs. We've implemented those resources in terms of mapping onto the consumer directory and the provider directory database objects. It's more of a relational database than in HAPI-FHIR. They're stored as big JSON objects and linked together using linkages in the consumer directory and provider directory. We're storing them in tables, and so we use the Salesforce RESTful API development tools to accept the same kinds of objects and produce the same kinds of results. Well, you didn't get to do much programming.
Hi, I
Kathleen?
wanted to know if you're considering maybe reaching out to the HART-UMA group to see if it were possible. I think they'd absolutely love to be able to bang on the consumer database to see if they can have an UMA authorization server, which could do things like enforce their consents and even delegate that Trish and Joan can share the records between themselves. And if you're interested, I think you already have been talking to Debbie Bucci, but there's also Eve Mahler, so we could talk. But I think they would love to be in the sandbox.
Once we get a little further along, actually we have not implemented the consent directive API in the consumer directory yet. It's still a little too fluid, but because it's a standard DSTU2 resource, the patient generator generates them, and the HAPI-FHIR server has some examples. So you could go against that.
You wouldn't need the consent directive at this point. What we're talking about in UMA is the consent directive is the thing that talks in the background of the UMA OAuth profile and sets up the contracts between the authorization server and the data subject or the owner of the resource, and sets up the policies. But they're talking this information through the OAuth tokens, the permissions.
Okay.
So
well,
you would
let's talk further then.
Yeah, I think that they when you're ready.
Thank you. Any other questions? Here I've taken what was supposed to be an interactive hour and turned it into a lecture. But I hope it was useful, and I hope you've enjoyed the day. We've been spending a lot of time learning about a number of different aspects of FHIR and from a number of different perspectives. For me, it's been very useful. I hope it's been useful for you too. We also got to experience our very own power outage. An extended lunch break. I think that's all we have today. Thank you for coming. I'd like to also thank the MiHIN staff for putting all this together, and for our audiovisual folks for making it all happen and making it go smoothly when you had electrons.